Hi, this is another video about ESP-RFID boards. This particular one is designed by our community member called Alex from Russia. His GitHub name is Teriel. It's mostly same or very similar board to the previous one that we designed. The only important difference is the pin numbers and the pinouts on the side connector. And other than that, it's pretty similar board. It has some important features like input protection, polarity protections, and basically that's it. Also, maybe worthy of saying is that it's only 12 volt board because it uses 12 volt relay for the opening and controlling the lock. So if you overpower the board, you can damage the relay. Where here, the relay is isolated. It works on 5 volts. It's positioned after the buck converter, so you can even supply a bit higher voltage or even the lower voltage, like 8 volts on this controller, and it would work fine. So let's explain the setup we have here. Basically, it's something which I think most of you would be using, at least the lock and the reader. Here we also have the button for opening the lock, which is connected directly to the controller board, and door status sensor. Of course, these cheap dummy Weigand readers are pretty common and pretty universal. Most of them are powered from 8 to 16 volts DC input. They all have 2 data lines for the Weigand protocol, and sometimes you also get lines for LED, for the buzzer, for Weigand format, and sometimes even the doorbell button, which is just a simple switch that you can use to wire your doorbell and to control it when somebody presses it outside of the doors. So let's power this up and see how is this working. I'm gonna explain some more details about some particular parts here. Once you power the board up, usually the default firmware that you're gonna get here, well, if you buy the blue board, it will be already preset with the latest firmware, usually from the dev branch. But if it is not, then it's really an easy setup. When it powers up, if there's no access point set to connect, it will go into its own mode. So you go to search for the wireless networks and you're gonna see ESP-RFID or ESP-RFID blue, usually called like that. You press and you connect to that access point. Once you're connected, you go to its default page, which is 192.168.4.1, and default password is admin. You'll log in and basically get the overview of the status on your board. Then we can go through menu. There's some wireless settings, hardware settings, general settings, MQTT. There's users list, and there's also some log management and so on. This particular firmware is still in the dev branch, so maybe you should go and check it out. Let's make a short overview for the hardware. Since this blue board has its own particular pinouts, and it's also possible to connect some other type of RFID readers. In this particular case, I had to adjust it. So I chose the reader type, which is Weigand in this particular installation, the D0 and D1 data pins, and as you see, it's number 13 and number 12. So it matches the pins here. Then I also selected the Wi-Fi LED status. Here on the side we also have that number 2, which I chose, and coincidentally it's also the number of the pin here that controls this LED, this LED, this blue LED on the ESP module. So it matches, these two LEDs actually matches. Now it's green, but default color, if that line, which is blue wire in this particular case for this reader, if it is not connected, it would be white. We go on. So the door status lock, door status sensor, simple magnetic switch which you position in your doors. It's connected to GPIO 4, which is also available on the side. And open lock, which is like the button that you're gonna use. This one is GPIO 4. So sorry, the door status was number 14 and open lock was GPIO 4. Then you have some additional settings for the relay, depending on how many relays you have in this particular board. And all these ESP-RFID boards, they by default have only one relay, which is pretty sufficient if you're going to control one doors. And then you choose the number of relays and you choose the relay pin, which is for this board GPIO 5, type of the lock, and activation time. So you also get this nice test button, which when you press it, it's supposed to open the lock, actually to test the circuit, to test if you connected your lock properly and so on. So as you see, when I pressed the test button, I was able to open the lock. Furthermore, here in the users list, you have the list of the users and the card numbers that you added into the system. Essentially, if the user is added and if it has the activate status always as access type, he is able to log in with a card. If he is not there on the list, he won't be able to open the lock to activate the relay. So this card is added into the system, and this token, this keychain, is not. It also has the RFID chip in it. So when I put this token on the reader, you saw I got the pop-up. It only appears when I'm in this user page, the setup page for the users, and it actually enables me to easily add some new users. And now if I would go and enter the name for this user, for example, Nardev, and if I give it the access type, let's say disabled in this case, which is uncommon, but just to have the two different options with two different tokens. And when I save this, I would have to log in again. If I refresh the page, I'll explain why. If you go to users page, you see now we have two users, but one is disabled. Now in this mode, you can't see the information that it's disabled, but if I think if I go in the landscape mode, I would get wider table. Yeah, I would get wider table. Basically on your desktop or on your computer, you can immediately see which user has the access right or doesn't have the access right. Okay, so since this card is already added there, if I swipe it, it's supposed to open the lock. This card is in the system, has access right. The lock was opened. This one is also in the list, but is disabled, and basically nothing happens. You just get, if you have MQTT and Wi-Fi enabled, if you have your broker set, you would get the message on your broker that somebody tried to access the reader, swiped the token, but it was invalid. Let's go a little bit more through these settings. Oops. You have the wireless network. It's sometimes laggy on this interface, but usually it works okay. If you press scan in the client mode, you'll get the list of the Wi-Fi networks. You set the Wi-Fi network, and you can even set the static IP address, and you get connected, and you can access this same interface through the IP address of the device. There's also MQTT settings. You set the settings for your broker, and you can also enable to send some more information to the broker. And that's about it for now. There's also some log files. You see it works fine now, but sometimes it can happen that the log files stuck the communication with the device. The reason is that this interface actually loads in immediately in the beginning. When you log in, you get the whole page because it's just a single page, and then the communication between the web configurational page and the device goes through a socket, and they're exchanging just JSON messages. Also important for mentioning, once you make certain changes, for example, and you want to save that, you get this yellow notification in the bottom, then you press it, and you basically get an overview for the configuration that you are going to push to the device. You press save and reset the device, and then it uses that new configuration. So let's talk a little bit more about this particular lock, because this could be interesting for some of you. As you see, it only uses 2 wires, and it's connected directly to the controller board. The reason is that it's just a simple coil in this particular one. Some other locks could work differently, but this one works fine in this setup. And in the bottom here, you have 2 3-pin connectors. And actually, it's just pins from the relay. And you have several ways of connecting and controlling the lock here. One of which is directly controlling the lock with second from the left and third from the left pins. What it does, the second one is connected to the ground always, and the third pin will be connected to power once the relay is activated. So basically what you get is, in the moment of giving access to a user, you just power the lock. It powers the coil inside the lock, and it opens the lock. And that's about it. In some other installations, you might want to use the cold switch or unpowered switch. And for that purpose, there's the middle 3-pin connector here, because it's 3-pin, 3-pin, and 2-pin connectors here. It's hard to see maybe on the camera. So you use the second one, and you have there also the similar situation. You have constantly connected and only connected during the powered state, during the activated relay. So you choose what you need for your lock, and you connect your lock that way. By using the second 3-pin connector, you're also able to power the lock with the AC power supply that are pretty common on the entering doors with these magnetic locks. Here we didn't check this door status. I can't show you right now because all you're supposed to see is the message which is being sent to MQTT, and the message is being logged once this magnet is separated or once this magnet is connected. And here is the opening button, which some of you might want to use inside the protected area. It's interesting because it is connected to the controller and it's not directly activating the lock. It actually sends the signal to a controller. Controller gets that input, sends that to MQTT, logs that to its internal log, and then opens the lock. So basically you have the information that somebody opened the lock with an inside switch. And it's like this. Once you press it, you get access and you let somebody in. Yeah, I have some extras actually. Here is the new ESP-RFID, the newest one, which is integrating everything in single board. So here we have the RFID modules. One is for the MIFARE 13 megahertz, 13.56 megahertz cards, and another one is also the Weigand standard reader. So it's possible to connect the controller whichever you need. There's RGB LEDs here on the side, there's a buzzer, there's a relay, and it's also possible sometimes to power this with a 5-volt USB power supply. That's of course in the case that if you don't want to control your lock, or if your lock is possible to be controlled with 5 volts. So how it works, it's placed inside of this enclosure. Of course, keep in mind that this is not for some very secure environments, because whoever has the access to this box, to the reader, can also exploit it, open it, control the relay directly, open the lock and so on. But it can be used in many other places. So you have everything packed inside of one box, and I have the test firmware here. We're gonna add a custom firmware for it a bit later in the repository, and some schematics for this one. But let's just power it up a little bit with the test firmware. Okay, it also works from the 12 volts, and maybe you heard the click of the relay. It's just a test firmware to check the LEDs and to check the buzzer. So it's nothing fancy right now, but it's all we needed to check the board. So stay tuned. See you. Bye.